Hello students, myself Reshma Gosavi from Utkarsh Vidhyalaya Virar. We are going to study a very interesting chapter today, that is from section Science 1 class 10. Name of the chapter is Periodic Classification of Elements.
Hello students, today we are going to study a very interesting chapter of Science 1, that is periodic classification of elements. Classification of elements, the basic things we have already studied from the lower classes. This year we are going to study it in much more details. Now first of all, the first question that comes in or arises in our mind is why classification of elements or classification is necessary. Students, you have number of books with you, that is textbooks, notebooks, workbooks and all. But how do you arrange themselves? That is, you keep separately the workbooks, the textbooks and the notebooks. And that only is the basic thing of classification. Okay, classification helps in managing the things properly, right? So after arranging them in proper order, you give the names to the subjects and all, and etc. So this helps you in classifying the things in a proper way. That's what we are going to study in detail about classification of elements. So this is the answer for necessity. Now, why there is a need for elements to be classified? As we know that the number of elements available right now, that is, might be they are naturally available or they are artificially prepared in the laboratory. There are in total 118 elements. Now it was not possible during 18th century to study such, maybe the number of elements were very less, but then to segregate them all together and to study the property of each and every element separately was not possible, and henceforth the scientists during those time thought of classifying the elements. Okay, so this classification starts with the first scientist whose name was Dobryns. Now, who was this person? He was a German scientist who had learnt or studied the elements in detail available during that time. The number of elements, of course, were very less, but still he arranged them in the increasing order of atomic mass. Actually, atomic mass is the most fundamental property of the element, was the understanding. Henceforth, what he did was arrange them in the ascending order of their atomic masses. After arranging them in the order, what he noticed that the first three elements were having similar chemical properties. Now, after arranging them in this order, what he did was he made groups of three elements as they were similar in their properties. Nextly, one more thing he noticed, that the atomic mass of the middle element is equal to the average atomic masses of the first and the third element. And henceforth, as this was related only among the three elements, his law he named as Dobryns Law of Triads. Henceforth, we will see an example related to this, that is the atomic mass of, let the lithium be A, atomic mass of, let the sodium be B, and the atomic mass of potassium be C. So according to his law, what did he say? A plus C, that is atomic mass of lithium plus atomic mass of potassium divided by 2 will give you the atomic mass of B, that is sodium. So 6.9 was the atomic mass of lithium, then 39.1 is the atomic mass of potassium, which when divided by 2 got as 23.0, which was then the actual mass of sodium. And thus this example, it obeys Dobryns law of triads. Okay students, not only this, but there were still many more examples which were proving Dobryns law of triads. Now, what is the thing is that when these examples Other examples may be strontium, barium, and then chlorine, fluorine, bromine. Like this, there were still many examples available. But then what happened is this law was not being proved for the newly discovered elements. Henceforth, this law cannot be followed by the other new elements. Now, as the science progresses every time, every day, so another scientist who contributed in this classification of element was Newland. Now, Leibniz, what he did is he also followed the same procedure, that arranging the elements in increasing order of atomic masses. Now, what he got that after arranging them in the increasing order, the property of the first element was similar to the property of the eighth element, as it is seen in the musical octaves. And so he named it as Newlands Law of Octaves. Okay, now here you can see that in one group we can have hydrogen, fluorine, chlorine, such elements. Why? Because they were having similar chemical properties. Now, there were some limitations too. Now, what were those limitations? That here you can see cobalt and nickel, two elements which were dissimilar in properties of this group, were placed in the same group. Actually, cobalt and nickel, both the elements, two elements cannot be placed in the same group, right? Again, there was another example, that is cesium and lanthanum. Again, these two elements, one at a time, were placed in the same group. Okay, this was one limitation. Then another limitation is here you can see iron. Iron, which is a metal, which was placed along with oxygen and sulfur, which did not match with the properties. Similarly, for cobalt and nickel were not matching with the properties of these elements, that is fluorine and chlorine, which were considered as a halogen. And after all, after this also, the classification was successful only till the element calcium. That is, the Newlands law of octave was successful only till the classification of calcium. Then further, when the newly discovered elements were further discovered, those elements were not having a proper place in this Newlands classification of elements. Henceforth, this scientist was also not successful in proving his law. Now, the third scientist who came or with the new idea again contributed in the classification of elements, and his name was Mendeleev, Dmitri Mendeleev. He started his work from the year 1869 and contributed his work for the same. Now, what he did during his time, the number of elements were 63. He made a detailed study of all the elements, and then he arranged them in this proper order, that is, say, in the proper table. This table also we can call as periodic table. Okay, now here you can see there are vertical groups, that is group 1, 2, 3 to group 8, and there are horizontal columns also in the Mendeleev's periodic table. Now here you can see R2O, RO, R2O3. These were the compounds formed with the help of the oxygen and hydrogen. That means the compounds of oxides and hydrides, right? Now here, if you see R2O, actually this is a compound. It is a compound formed by the element of group 1 and oxygen. Right now, we write the valencies below the elemental form. But here, during his time, during Mendeleev's time, the valencies were written at the top. Okay, this was a difference. Now here if you see R2O, that is valency of oxygen is 2 and valency of R, that means maybe a metal which is having valency as 1. So here the compound formed is R2O. So it is crisscross written as R2O. If you go to group 2, it's written RO. That means it is understood here that the element of group 2R and the oxygen form a compound and it gives RO. As both are having valency 2, so when we crisscross it, we get the compound as RO. Okay, so now the these were the points of the classification in the Mendeleev's periodic table. Now these, as we compare with the classification of the periodic table with the previous two scientists, this scientist had done a great work in his contribution of classification. There were very many merits of the Mendeleev's periodic table. Let us have a look of this. Here you can see the merits of Mendeleev's periodic table. The first, just go through the first point, that is atomic mass of some elements were revised so as to give them a proper place in the periodic table. Now what he did was, whatever number of elements were present during his time, that is 63 elements, he made a detailed study of all those elements present during his time. And what he understood, that some of the elements were having a different atomic masses, because as his main criteria was that his whole table, whole classification was based on the atomic mass. So what he did is, he first of all checked all the atomic masses and he came to know what, that beryllium, whose atomic mass was 14.09, and when he revised it, it changed to be 9.4, and henceforth its place in his periodic table was changed and brought before boron. Second point, that is Mendeleev kept some vacant places in the periodic table. You have already seen that in his table he had some vacant places. Can you see this? So in this vacant places, what was his idea? That in future, whatever elements are discovered, those elements should have a place in his periodic table. So that idea came to be very important. Now what he did is that he gave some false names to those vacant places, and three of the names were Eka boron, Eka aluminium and Eka silicon. Now after discovery, they were named as scandium for Eka boron, gallium for Eka aluminium and germanium for Eka silicon. And not only this, but he predicted some properties also, which were chemical properties, physical properties, and those properties were actually approximately matching with the properties when the truly available elements were discovered in future. Okay, so this was the second merit. If you go to the third point, that is noble gases such as helium, neon, argon, which were discovered later on, were given a special place. Now during his time, there were no noble gases available. But as the science progresses, these inert gases or say noble gases which were discovered later on, he gave them a special place in his whole classification of periodic table. Okay. Now coming to the next one, that is demerits of Mendeleev's periodic table. As there were merits, there were some minus points also. Just go through the first point. There was an ambiguity, that is confusion, regarding the sequence of elements in the Mendeleev periodic table. Now what happened is, thus atomic masses of some of the elements, like for example cobalt and nickel, were having same. That means, for example, if they are in decimal forms, then the whole number of cobalt and nickel were one and the same. So there was a confusion that in which place, in which order they should be placed in his periodic table. This was the first demerit. Going to the second demerit, A challenge was posed in placing isotopes in the periodic table as the isotopes were discovered later on. Now, what are isotopes? Isotopes are such elements who are or which are having the same atomic number but different atomic mass number. So he never thought of isotopes, and thus it became a demerit that with different isotopes were a challenge because they were not having a separate place, an individual place in the classification of elements. Thirdly, the third demerit was rise in the atomic mass does not appear to be uniform. Actually, his baseline was what? That the elements are arranged in the increasing order of atomic masses. But while arranging them in the order so that the chemical properties of the elements, similar chemical properties, should be given a same group, in arranging these things, what happened is the uniformity of ascending order was disturbed. And so it was not possible to predict how many elements could be discovered between two heavy elements. Next, number 4 demerit is that position of hydrogen in the periodic table was not fixed. This was a very important demerit. Now, as we know that the hydrogen valency is 1, and of course it matches with the valency of alkali metals like lithium, sodium, potassium, and also it matches with the valency of halogens like chlorine, fluorine, and bromine. And so whatever study was done regarding hydrogen, there was a confusion, and so in his classification he didn't get a proper position for hydrogen. And so these were the demerits of Mendeleev's periodic table. Now, of course, if the demerits are there, then those demerits have to be rectified further. And henceforth, regarding this only, the another scientist who contributed and whose contribution is very, very important in the classification of elements, that is then in the next part, whose name was Mosley. So this person whose classification still we go on and continue in this classification of elements. Now here you can see a modern periodic table. Of course, the number of elements which were present during his time were the most number of elements. Now, what he did was a drastic and a very important change in his table was that he considered modern periodic table on the basis of the atomic number. What he did was he studied all the elements and he followed the same procedure first of all which was done by Mendeleev. During Mendeleev's time, he had made a deep study about the electrons, protons, and neutrons. And henceforth, the importance of the electrons, protons, and their properties was continually studied by the Moseley. And so, he gave importance not only to the study, but he arranged the elements in the order of increasing atomic number. Now, this atomic number actually was only a serial number in the Mendeleev's periodic table. But in modern periodic table, he arranged the elements on the basis of atomic number. Okay. Now, here if you see the elements, hydrogen, and after that directly the helium, right? So here we can see the increasing order of the atomic numbers. So he made his law that the physical and chemical properties of the elements are the periodic functions of their atomic numbers. That means after a definite interval, the properties of the elements are repeated. But the main difference was that it was based on atomic number. As it was based on atomic number, so many of the demerits, of course, were rectified automatically in the modern periodic table. Okay, so the isotopes point and all was totally discarded. Now, here if you see, that is in modern periodic table, The table is classified into three ways. That is, in the first way, the modern periodic table is divided or classified block wise, then period wise, and group wise. Okay,